Mission Atlantic, to ensure a sustainable future for the Atlantic Ocean. Integrated Ecosystem Assessment, or IEA, is a holistic approach to managing ecosystems by evaluating the cumulative impacts of natural variation and human activities. It follows an IEA loop that starts with scoping the system, together with stakeholders developing indicators, analysing the risks from and to different parts of the system, testing potential future scenarios under natural and anthropogenic change, and refine focuses on revising and improving the assessments based on the outcomes and insights gained from earlier stages in the cycle. This process helps balance trade-offs between ecological health, social well-being, and economic viability, ensuring sustainable use and conservation of ecosystem services. The indicator development phase is crucial for monitoring the health and trends of the ecosystem. By developing and selecting robust, relevant metrics to monitor ecological, social and economic dimensions, managers and decision makers can identify and respond to developing challenges in an informed and timely manner. In this video, we are introduced to a tool focused on analysing the spatial distribution of species in response to their environment. Our guide Mireia explains why the tool GAM-NICHE is different from standard spatial distribution models, how the results from these models can provide indicators for IEA, and how to assess the results of management actions.
Hey everyone, I'm Mireia Valle. My research area focuses on global change in marine environments. I work in AZTI. In this short video, I will introduce to you the GAM-NICHE model, a new tool we have developed to build species distribution models under the ecological niche theory. This e-learning training material is part of Module 3, Assess Ecosystem, and addresses the specific learning objectives related to data and information compilation to support ecosystem assessment and application of tools to detect trends in spatial and temporal data. Species distribution models are numerical tools that combine observations of species occurrence or abundance at known locations with information on the environmental or spatial characteristics of those locations. SDMs can be used to predict spatial and temporal trends in the distribution of our species of interest. While a variety of statistical methods have been developed for species distribution modeling, a general problem with most of these habitat modeling approaches is that the estimated response curves can display biologically impossible shapes, which do not respect ecological niche theory. This is because species response curves are fit statistically with any assumption of or restriction, which sometimes do not respect the ecological niche theory. To better understand a species' response to environmental changes, SDMs should consider theoretical backgrounds such as the ecological niche theory and pursue the unimodality of the response curve with respect to environmental gradients. Here we present GAM-NICHE model, a new tool which consists in a tutorial on how to use shape-constrained generalized additive models to build SDMs under the ecological niche theory framework. These models impose monotonicity and concavity constraints in the linear predictor and avoid overfitting. And what is GAM-NICHE for? You can apply the tool to marine and terrestrial species with many different objectives. Here I will mention some of them. For example, we can use GAM-NICHE to estimate species distribution, recruitment, spawning, or cartography. We can also use the tool for determining main factors affecting species distribution. We can also apply the tool to monitor and do trend analysis. We can use the outputs from the models to guide restoration, identifying suitable areas. We can also explore shifts in biodiversity, and we can also explore climate change impacts, or use it for policy advice, recommending areas to protect. We can also assess anthropogenic pressures. And finally, we can use GAM-NICHE for identification of exploited and unexploited areas. GAM-NICHE could be applied in all Mission Atlantic case studies. Here we saw some example results. In this study, we developed 3D habitat models of the main commercial fish catch in the Atlantic Ocean. In the figure, resulting 3D cumulative probability map is shown for Tunus alalunga as an example. After modeling each species occurrence probability, we estimated the potential catch biomass based on that probability, and we generated these two overall potential biomass catches maps. The first one for the main commercial fish species and the second one for the modeled tuna species. The results fit within the integrated ecosystem process first loop by helping to assess ecosystem status, and they fit in the subsequent loops, helping to implement management action. The resulting maps can also directly inform managers and provide policy advice. Please visit the following links for more details in the method, and please do not hesitate to contact us if you need further help. Thank you very much, and I hope you enjoyed this short video from Mission Atlantic Integrated Ecosystem Assessment e-learning modules. Bye!